Welcome to this example. It is for students who are either studying the introduction to vector addition, or you're possibly in physics and you're doing some of the resultant force calculations, okay, so that you might run into. Now, you actually don't really need physics to be able to solve this, but you certainly do have to understand vectors a little bit. So that is going to be my assumption. So my assumption is that you're comfortable in trying to add, okay, and subtract vectors. Now, if you want, okay, you can certainly go through a little bit of a review on addition and subtraction of vectors. I'll put up a link up above there, okay, so before you dive into here. And, you know, if you have already, okay, under your belt, okay, the actual addition and subtraction of vectors, you are familiar with that concept, okay, then let's try to solve this example. Now, this example has three forces, and forces, okay, are actually vectors that we apply. Now, the examples that I've done in the past are typically with two particular vectors, but here we're going to have three, and I just want to show you, you know, that it will be a little bit painful, but it certainly is doable and actually pretty understandable. I'll try to break it down for you, okay, how you can approach these questions. So here it is. We have three forces and they're present on an object. So what I like to do is whenever I'm working with anything to do with regards to forces, I like to visualize things, you know, so I'll write out whatever possibly is given to me. And in this case, if it's telling me that I have three forces present on an object, I kind of like to draw an object. Now that object, it doesn't matter what it is. You know, you can draw a square, a rectangle, okay, a circle, it doesn't matter. So here's my object, and now I'm going to be applying forces to this particular object. So it tells me that my first force that I am dealing with is 26 newtons, and it tells me the angle of that particular force. And if it's a vector, then obviously we need an angle. Now, sometimes it might be just purely horizontal, sometimes it might be vertical, but in this case, okay, it is not. It is actually at an angle. So what you can do is, okay, so with regards to this, you can certainly attach. So as you have, you know, this particular, okay, object, I'll make it square so that it is actually, you know, kind of symmetrical for us. So what you can do is you can draw yourself, okay, right through the center of this object, you know, an imaginary axes, both the x and the x axes, x and the y axes, okay, for that object. And with regards to that axis, now you can proceed. I'm going to do it in, I guess, maybe pink. Okay, this is going to be my first force that is applied, and it's 26 newtons. Okay, and I know the angle, so it's from north and it's 30 degrees, okay, east. So it's going to be, you know, more or less, okay, so something along this line. That's going to be my actual force which is applied. And I know that the angle there, okay, so this particular angle that I have, so this angle right here, it tells me that this is 30 degrees. And that's going to be my first force. So I'm going to write it F1. Okay, it is a vector, and it is equal to, at least in magnitude, equal to 26 newtons. So that is the first thing that I'll do. Now, my second one, so notice it says it's 47 degrees, and it's 45 degrees from the horizontal. Okay, so this one, maybe I'll do a different color. So I'll do all of them in different colors so that they really pop for you. So 47 degrees is obviously bigger. So I'm going to make this and shift it out a little bit, make it smaller, you know, shift it out, okay, let's say over here, so it doesn't interfere. And 45 degrees is, you know, so that one is relatively easy to draw. So this is what I would have. Now 45 degrees, I'm not actually scaling this, you know, per se, but it is going to be bigger than my first force which is applied. Now, this is telling me that this is, okay, at an angle of 45 degrees, and the magnitude of this one is 47. So I'm going to call this F2, so that's my vector. Okay, I'm taking the magnitude of this, and that magnitude is 47 newtons. So that's what we have so far. And then I have a third one right here, and this one is at 80 newtons, and it is, notice, starting from south, and then it goes 60 degrees west. Okay, so that's a little bit weird, okay, in terms of quadrants, but so be it. And this one I'm going to do again in a different color. So maybe since I used pink and green, let me maybe use orange for this one. Now it's 80 newtons, so it's going to be the largest one, and it's 60 degrees west. Okay, well, from the south, so it's going to be, you know, something along the lines, okay, over here. Hopefully this draws it out, okay, so it's going to be something along there. Okay, so that's what I have. And this is my angle. So this is the angle, so this is what it's telling me, and this is 60 degrees that I have. So notice starting from south and then going west. So that's why I put it in that way. So here would have been my third force. Okay, that's the magnitude that I have. And within here, this is supposed to be 80 newtons in terms of its magnitude. So notice I put magnitude, I put the absolute values to designate that, and then I show the angle. And really, so what we want to be able to do right now is we want to be able to say, what is the resultant force, okay, that we have? Now, the resultant force is equal to the summation of the three forces, F1 plus F2 and then plus F3. So that's what we really want to be able to do. And these are actually vectors. So you might say, boy, this is going to be kind of hard. Yes, it's correct. And what we're going to be trying to do, because normally when you're starting to talk about vectors, you know, you draw them and you draw them proportionally and so on. Okay, and then you can, you know, play around with your arrows and then line them up to try to see, you know, what the result might be. That's great, you know, if you can actually proportionally scale and then you can utilize your angles and then find out exactly. But you're going to be guessing a bit, so you can find an estimate of the result, which might be okay for you. But what if you want to find exactly what it is? So what we're going to be doing is, so these three particular vectors or forces that we're dealing with, we're going to break them down into both the x and the y. So I'm going to do them one by one. So since I picked kind of pinkish, or magenta there, I guess pinkish, okay, as my force number one, so this is going to be my first force, okay, F1, and I'm going to break this down into its x component and into its y component. So that's what I want to be able to do. So that's my force, okay? So this is what I'm going to have. So I'm going to take this, all right? Okay, I'm going to take it, or I can, you know, I can certainly redraw it if I wanted to. Let me copy it. I'll bring it down, paste it, okay? So here it is. You know, here's my actual force. And now I'm going to be able to break it down. So I'm going to break it into its x and y components. So this is going to be kind of the y, this is going to be the x. That's what I'm going to be trying to do here. All right, so that's the force in the y direction. It's going to be up, and then that's going to be the force in the x direction, which is going to be to the right, because that is how this vector is working. So how am I going to do that? Well, I know the angle, right? So now I know the angle, which is right here. So this angle to the horizontal is 30. Well, that's not really a big deal for me, because that means that this is going to be 60 degrees right there, because, you know, that's going to make the right angle there. So 30 and then the 60 is 90. So I can break this down. So what I'm going to have is my fx is going to be equal to, and now all I have to know is what is the magnitude. So this is going to be 26 newtons, right? Multiplied by, and whatever that is, which is cos of 60 right there. And that is my x component. Now, cos of 60 is actually not bad. So I guess that's a half. So this is going to be half times 26, which is 13 newtons, at least in its magnitude, right? And it is to the right. That's what I would have in here. Now, my y component would have been 26 newtons multiplied by now sine of 60. Now, certainly we can do that. I guess sine of 60 is going to be square root of 3 over 2. Now, let's round these up, okay, a little bit, again, just as we're playing around, and if you're going to be doing this, okay, so we can certainly do that. So it's going to be 26 multiplied by, sine of 60. So we'll put that in here, and let's round it to maybe 2 decimal places for us, unless, something says something different. But I'm going to be rounding this out, and that's what I'm going to get. All right. So those are my 2 components so far. So this is the component in the x, okay? This is the component in the y, and they're both positive. That's the first thing. Now, what I'm going to do is, this is f1. Now I'm going to break down f2 in exactly the same format. So for f2, it's green, so I'm going to take a green in here. And I'm going to break that down as well. So this is number 2. This is the second vector that I have. And for that second vector, so this is what it is, okay, kind of right here. I can certainly borrow this. Let me copy it, okay, paste it down in here. And that's my actual vector, okay, that I have. And now breaking this down just as I did with the same thing on the first vector, so I'm going to have 2 components. I'm going to have a component in the x. Okay, so this is for number 2, I guess. So let me just, write a little 2 in here, and I can certainly write a 1. So let me write 1 and 1, just so that it aligns with that, although I guess you can see the color coding with here. So now I know the angle, so the angle here is 45 degrees, so that one is very easy to work with. So 47, multiplied by, and it's going to be, okay, cos, okay, of 45 degrees. Well, cos of 45 is 1 over square root of 2. So I can certainly find out what that is. And again, I can, okay, round it up. So 47, I guess, divided by, this is going to be square root of 2. So this is going to be 33. Okay, and since I'm keeping kind of 2 decimal places, so I'll keep that. Now, my y component of 2 is going to be the same thing because, again, unit circle, if you recall, so this is 45 degrees. Okay, so I'm not going to, recalculate this, okay, at all. Now, this is newtons, right? So this is all newtons, okay, that I am dealing with in here. And those are my values. So now I have 2 broken down components of my vectors. Right? Now, all of these are positive, so they're both to the right, okay, and up, because that's how my vectors are. Now, my third one that I'm going to do, so here is my third one, I guess it was orange. So if I would write the third one out, this is going to be f number 3, and if I want to be able to do that, so this is this one, okay, that I have in here. So let me grab it. Okay, so this one is the largest one. So I'm going to paste it down. Okay, so this is what I have. And I guess, let me just do it, okay, in here. And now, so I need my x and my y components. So here I'm going to change this, kind of color code it for myself. Well, here's my x component. At least that's what the one that I'll have. And then here's my y component. Okay, so this is what I will have there. So this is now a little bit different because just the way that it falls. But this is my f, 3. This is x component. Notice it's going to be negative. And then this is going to be f, my y component for 3. And then again, it's also going to be negative. So it's going to be down for me, right? In terms of its direction. So those are the components. Now, in order to find them, well, this is not really a big deal to do that. So I do know the angle. So if I go back in here, so that's 60. So that was 60 with respect to here. So from south going west. So that means this angle is 30, right? So this is actually 30 degrees, okay, in this direction. So if you're breaking this down, I can find out what that x component is. So it's going to be 80 newtons multiplied by, and I guess this is going to be cos of 30. Okay, so this is what I have right there. And for that, I guess, cos of 30, so that's going to be square root of 3, right, over 2. So I can calculate what that is. Let's just punch it in here. So that's that multiplied by, so cos, okay, of 30. So I'm going to have, so this is approximately 69, 28 newtons. But it is, so I'm going to put a negative because it's to the left. Now, my other one is going to be no different. So this is Fy for number 3. It's going to be 80 multiplied by now sine of 30, right? Well, sine of 30 is just a half, so I guess this is going to be 40. This is going to be negative 40. I'm going to put the negative because it's down, okay? And so again, so please recall, so sine of 30 is just a half, and then times the 80 that I have in there. So now I have all my components, right? And now you can find out what your resultant vector, okay, is going to be. So now my resultant vector, so f, at least with respect to, okay, the magnitude, right? Now I can find out, okay, first, what is its, right, in terms of its x component. So what that x component is, the magnitude, and that's going to be, I can take all of these. So I have 13 newtons, right, from the first one, okay, that is to the right, plus, okay, the second one, which is 33.23, and then the last one, which is minus, so notice I have minus there, and that one is rather large, so it's 69.28. So what does that tell me? Well, that tells me, okay, that in here, so this is going to be 13 plus 33.23, and then minus 69.28. So here it is. So I have negative 23.05 newtons. So that is my x component. So it's going to be to the left. Now, my y component, so if I want to find the magnitude of that, okay, what it's going to be is, so if I take those, so if I go back in here, it's going to be 2252. This is going to be 2252. Plus the second one, which was 3323. So 3323. And then the last one, okay, minus 40, because it was down. So let's see what this is going to come out to. So 22.52 plus 33.23. And then minus 40. So this is, actually it's positive, so it's going to be up. So this is 15.75 newtons up. So what you've now created, okay, and if I kind of redraw this, so here is my, my x and my y axes, okay, so in here, so if I do this, okay, this is again, remember, it's just imaginary, these axes, but they do help us. So I have, okay, so within here, so let me do it in maybe blue, okay, and I'll dot it out. So this is in the negative side, so 2305. So it's going to have, okay, so this is my, okay, whatever this is right here. So let's say this is the 2305, so it's on the negative side. And then my y is positive, so it's 1575. Right, so this is going to be 1575, okay, so in this particular direction, and that is my resultant vector. So my resultant vector is going to be looking, okay, something like this. That's how it's going to look like. And now you can certainly find out exactly what it is, right? You have the x component, so this is 2305. You have the y component, which is 1575. So I can find out what my resultant vector is, at least in its magnitude, and I can certainly find out what this angle is, right? Because it's just opposite over adjacent. So let's do that. So that's going to be 1575 squared plus 2305 squared, and of course we have to take the square root of that, and let's see what that would give us. So here's my, okay, let's just square that. It's going to be squared. plus 23.05, and let's also square that. So that equals, there we go, and that answer, I guess we have to take the square root of this, which is, taking to the exponent of a half on your calculator, so you don't have to re-input that. So that's going to be 27.9, 1710, so on. I know that I have to round this at some point, and I will. So let me just see, okay, in the question, I think it says round the magnitude to the 10th, okay, so magnitude to the 10th. So let's say this is 27.9 newtons at, and now of course the angle, okay, that we need, we can find out what that angle is. So that angle is going to be, 10 inverse, okay, of opposite over adjacent. So 1575, okay, divided by, this is 23.05. And then, what is this? Okay, so let's try to see what that might be in terms of its angle. So clear this. So 15.75 divided by 23.05. Okay, so that angle is 34.3446, etc. Now, that is with respect to the horizontal, right? If you wanted to find out, let's say this angle right here, let's call this, theta maybe bar. Well, you can do that because it's just 90 minus this. So it will be whatever that answer was. Okay, let's say minus the 90. Okay, it's going to be 55.6. So what did it want? Let's see how they wanted the actual bearing there. And state direction quadrant bearing rounded to the 1. Okay, well, to the 1. That's going to be 56 degrees. Okay, so this is going to be, so I'm going to do it with respect to the north. So starting at north, so this is 56 degrees, and we're going west. And there is my full resultant vector. Now, because we had 3 of these, breaking it down into its components, x and y, is amazing. It takes a long time, as you can see. I mean, this is a relatively long video just for one example, but I didn't want to rush it, and I wanted to show you to just break it down piece by piece, and you can certainly do that with all of these, and then just add up these vectors and then find your resultant vector. So what that is telling us, that the net force, the resultant force is the net force, okay, is going to be pushing that object, okay, overall. So although you have 3 forces, okay, combined, but those 3 forces combined is going to be pushing the object in this direction with a force of about 27.9 newtons. It's going to start to accelerate in that direction if that is the, net force or the resultant force, either or depending on what you use. So that is it with respect to this example. So now if you can do this, you can certainly do many other examples with vectors. This is a planar example, okay, in kind of 2 dimensions, but it's a great example to show you and illustrate the power of vectors and then where we can actually use them. All right, so thanks for watching. So either, students who are studying vectors or students who are doing physics or will be doing physics, okay, I hope that this has helped you. Take care of yourself, and we'll see you in future videos. Bye, everybody.